Alright, this is my video for Game Engine Programming Sprint number 4. Starting off with the attorney client idiom. If we're looking inside of the, oops, that's not what I wanted. So the game object, if we look at something like the alarmable attorney, we have the public class game loop friend to the manager so that it can call the trigger alarm inside of the alarmable object. And then we have the public class registration, which is friends to both registration and deregistration commands so that they can be called inside of the alarmable object. And then if we are looking inside of the manager, something like the drawable manager, we will see that through the drawable attorney, the game loop class, we will call draw inside of the drawable object. So we won't access it directly. And then looking at the alarmables, been updated with 4 alarm functions and a struct registration data with all the appropriate data for each alarm, and then an array of the registration data. That is the size of the alarm number, which is how many alarms we have. And then inside of the constructor, we'll just flip through our array, initializing all the values to what they should be, creating the new commands, and setting each one to deregistered. The registration and deregistration commands work relatively the same, except now they'll go through registration data of ID using the alarm ID to set the proper ID values, and then trigger alarm will also use an ID that will switch through to call the proper alarm function. Then if we look at the, that's not what I wanted. In input, we have the keyboard event manager, which has a register and deregister, taking an inputable, a key, and the type, and then a map of all the single key event managers. And then whenever we register to the keyboard event manager, create an iterator inside the map, and then we will run through the map to see if we currently have that single key event manager, and if we do, we'll just set our pointer to that instance. Otherwise, we'll create a new single key event manager for that key and insert it to our map, and then regardless, we will call register on our single key event with that input and that event type. And then in the process key events, we're just running through all of our single key event managers and having them process their key events. Looking in the single key event manager, we have a list of inputables for both the press and release, and then a deregister, register, and process event, and the enum key state, which is used to keep track of the previous state of the key. And looking inside the actual functions, we have in the deregister and the register, we just check what type of input we're looking for, and we add it to the appropriate list of inputables. And inside the process key event, we are just checking to see for a change in the state to the previous state, and when we do, we'll run through the appropriate list of inputables and just call the key pressed on that inputable with the given key. And moving down here inside of the game object, we now have the registration state as well as the commands for enter and exit of scene, and then the proper functions to make that work. But looking inside of the CPP, inside the submit entry or submit exit, we're just calling in the scene attorney the submit command, either the game object enter or exit of the scene, and then those will call the execute inside the commands, which will come back to these functions here, and we'll either call scene entry on the game object or scene exit. And if we're looking in the actual game objects, so here in the frigate, we will submit key registration for the spacebar of the event type key press, and inside of that, when we get key press, we will call the bullet factories create bullet with our rotation and position. Look at bullet factory. Inside of our create bullet, we just check to see if we have any bullets in the stack. If not, we're creating a new one. We'll call initialize on that bullet with the rotation in position, and we will call the submit entry so that is added into the scene. And looking at the actual bullet, the initialize function, which sets all the variables so that they spawn on the ship, and then in scene entry, we're registering for update and draw, and we submit for an alarm for 1 second, which will then just call submit exit, which will then come back for scene exit, and we will deregister for update to draw, and we will recycle to the factory. And looking down in the plane, we just have, where this is the axis, we're just registering for the T key press, which will just output T was pressed on axis. And in the plane, registering for key input of T for both press and release, and the release of O. And then when we release O, we will deregister for key press on T, so then we will no longer see that call. But if we run this, move this side a little bit, the ship can move. We can see pressing T, we get T pressed on the plane and axis, and then the T released on only the plane. And then if I press O and release, I get O released, but I no longer get T pressed on the plane since it's now deregistered. And then if I'm pressing spacebar on the frigate, I will spawn bullets that will deregister when their alarm ends, and I can see the size of the stack. They get bigger the more bullets that I shoot. That is my sprint.